Hi, welcome to my channel. In this video, we want to solve the following problem using two methods. Triangle ABC is an equilateral triangle inscribed in a circle. Let M be an arbitrary point on the arc BC. Connect M to A, M to B, and M to C. Our goal is to show that MA equals MB plus MC. And now for the first method. First, let's show that MA, which is the length of this line segment, is greater than MC, which is the length of this line segment. Let's call the center of the circle as O, and then focus on the line segments BA and MA. Denoting the perpendicular distance of the center of the line segments MA and BA from O as DMA and DBA respectively. We see that DBA is greater than DMA. Since the line segment MA is closer to the center of the circle than the line segment BA, therefore MA is greater than BA. Next, focus on the line segments BC and MC. Again, denoting the perpendicular distance of the center of the line segments BC and MC from O as DBC and DMC respectively, we see that DMC is greater than DBC. Since the line segment BC is closer to the center of the circle than the line segment MC, therefore BC is greater than MC. Since BA and BC are the sides of an equilateral triangle, BA equals BC. Therefore MA is greater than MC. Since MA is greater than MC, let's define a point D on the line segment MA such that DA equals MC. With this definition, proving that MA equals MB plus MC then amounts to showing that MD, which is the length of this line segment, equals MB, which is the length of this line segment. Next, connect B to D. Before showing that MD equals MB, let's first show that triangle BAD, which is this triangle, is congruent to triangle BCM, which is this triangle. To do that, let's focus on the part of the diagram consisting of the line segments BA, BC, MA, and MC. Angle BAM and angle BCM are angles subtending the same arc. Since angles subtending the same arc are equal, therefore angle BAM equals angle BCM. Let's now turn to triangles BAD and BCM. Since the two sides BA, AD, and included angle of triangle BAD are equal to the two sides BC, CM, and included angle of triangle BCM. Therefore, by the side angle side or SAS congruence test, the two triangles are congruent. Since the line segments DB and MB are corresponding sides of congruent triangles, we have DB equals MB. Similarly, since angle DBA and angle MBC are corresponding angles of congruent triangles, we have angle DBA equals angle MBC. Following this, let's focus on the part of the diagram consisting of triangle BDM and the line segments BA and BC. Since MB equals DB, triangle BDM is an isosceles triangle. Next, let's calculate angle MBD, which is the vertex angle of triangle BDM. For convenience, let's call angle MBC and angle DBA as X, and angle CBD, which is this angle, as Y. Then from the diagram, we see that angle MBD equals X plus Y. But X plus Y also equals angle ABC, which is this angle. Angle ABC is an interior angle of the equilateral triangle ABC and thus equals 60 degrees. Therefore, angle MBD equals 60 degrees. The base angles of triangle BDM, which are angle BDM and angle DMB, are thus each equal to 180 degrees minus 60 degrees divided by 2, which is 60 degrees. Thus, triangle BDM is an equilateral triangle. Since the line segments MD and MB are the sides of an equilateral triangle, we therefore have MD equals MB. Finally, we can prove that MA equals MB plus MC. MA equals MD plus DA. Since MD equals MB, MA equals MB plus DA. Since DA equals MC, we therefore have MA equals MB plus MC. And now for the second method. We shall use a theorem known as Ptolemy's theorem to solve the problem. The theorem is as follows. Given a cyclic quadrilateral ABCD, if the line segments AC and BD are the diagonals of the quadrilateral, then Ptolemy's theorem states that AC times BD, which is the product of the lengths of the diagonals, equals AB times CD, which is the product of the lengths of this pair of opposite sides, plus BC times AD, which is the product of the lengths of the other pair of opposite sides. That is, the product of the length of the diagonals is equal to the sum of the products of the lengths of the pairs of opposite sides. Let's apply Ptolemy's theorem to our problem. For our case, the diagonals are the line segments MA and BC, of which the product of their lengths is MA times BC. One pair of opposite sides is MB and AC. The product of their lengths is then MB times AC. The other pair of opposite sides is MC and AB, with product MC times AB. Since the line segments AB, AC, and BC are the sides of an equilateral triangle, BC equals AC equals AB. Thus, BC divides out and we obtain MA equals MB plus MC. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.